Hello and welcome to Factoring Perfect Square Trinomials Part 2. If you haven't watched Part 1 yet, I recommend you go back and check out the methods I used in that video to take a perfect square trinomial and factor it down into a squared binomial. This video we are going to be working on basically the same thing, except this time A is not going to be 1. In all the examples for Part 1, A was 1. This time, A is going to be anything but 1. So that's going to change some things and change our approach to it, but in the end, we're still going to be taking this perfect square trinomial, if it is 1, and we are going to be changing it into a squared binomial. So, without further ado, let's jump into it. Alright, here we have the perfect square trinomial, or at least we're hoping it's a perfect square trinomial, of 9x squared plus 12x plus 4. We are going to hopefully change this into a squared binomial, just like we did in part 1. This time, though, A, as I said, is not 1. A is 9 here. So we're going to have to do a little bit different kind of thinking for this type of problem. And we are going to have to include a different approach to it. Just a little bit. It's still going to be mostly the same. So the first thing we want to do is look at the squared term, 9x squared, and ask ourselves, is this a perfect square? Is there something that I can multiply by itself to give me 9x squared? Now we saw in the first video that if it was just x squared, we would have x times x. Well, this time I have 9x squared. So what times itself gives me 9? And hopefully you say 3 times 3. So 3x times 3x is 9x squared. Now, what about the 4? Is the 4 a perfect square? Yes, it is 2 times 2. And at this point, we might think we're done. We can be like, oh, this must be a perfect square trinomial. It's 3x plus 2 squared. But we haven't checked the middle term. Just because the first term and the last term are perfect squares doesn't mean the middle term is going to allow it to be a perfect square trinomial. And we had a little approach of what we were going to do in part 1 for this, but now that A is something different, we're going to take a different approach. What we are going to do is we are going to take the 3x, one of them from here. We are going to take one of the 2's from here, so times 2. And then we are going to double it. Now, let me write that in a different color. The doubling is not because of this second 2. If this was 5 and 5, it would be 5 times 2. It's always doubled. So don't get confused and think that I took this second 2 down here. So what is 3x times 2 times 2? Well, that is 6x times 2, which is 12x. And what do you know? 12x is the same thing that we have there. So the fact that the square root of 9x squared, 3x, the square root of square root of 4, 2. When we multiplied those two square roots together and then doubled it, gave us the B term, means that this is a perfect square trinomial, and the answer that we came up with over here is correct. It is 3x plus 2 squared. Okay, and then we could solve for this if we set it equal to 0. But we're not going to worry about that. That's in a different video. So let's try a different example now. Let's see maybe one that doesn't work out properly and will not go into a nice squared binomial. So let's take a look. Alright, so here is 4x squared plus 26x plus 49. Numbers got a little bit bigger, but that's okay. We still have what looks like a perfect square on the front and a perfect square on the back. 4x squared is the same thing as 2x times 2x. Remember, x squared is just x times x, and then we take the square root of 4, which is 2 times 2. we can do the square root of 49, which is 7 times 7. And we might want to jump ahead and be like, oh, this is just 2x plus 7 squared, but you do not want to do that. You need to check the middle term. This is going to be the one that makes the decision. So we need to take one of our square roots of 4x squared, so one of our 2x's. We are going to multiply it by one of our 7's, so times 7. And then all of that is going to be doubled. So 2x times 7 is 14. 14 times 2 is 28x. Sorry, 2x times 7 was 14x. 14x times 2 is 28x. And is 28x the same thing as 26x? Hopefully you're saying no. So this is not the case. This might be factorable a different way, but it cannot be factored using the shortcut, so we can say not factorable. Not factorable with shortcut. And we would have to use a different approach. Sorry for my bad handwriting. But yeah, it's all going to come down to this middle term. All going to come down to that middle term. Doesn't matter if the first and the last are perfect squares. That middle term is going to be the one that determines it for us. And I should say, if this first term isn't a perfect square or this last term isn't a perfect square, it's not going to work either. But if they both are and the middle term doesn't check out, you can't do this. All right, let's try one more. I'm not going to tell you whether it is or is not factorable, but I want you to try it on your own and then see the answer. So let's take one more look. So we have 25x squared plus 40x plus 16. I want you to pause the video and give this one a try using the methods we used for the first two examples. Is this a perfect square trinomial, and can we turn it into a squared binomial? So pause the video and give it a try. All right, hopefully you've given it a try. And you've discovered that, yes, it is a perfect square trinomial. 25x squared is 5x times 5x. 16 is 4 times 4. And then if I take 5x times 4 and double it, multiply it by 2, 5x times 4 is 20x. 20x times 2 is 40x. So all the pieces fit. So we can factor this down, and this is going to turn into 5x squared plus 4, sorry, not 5x squared, 5x plus 4 squared. And we didn't have an example like this, but remember from part 1, if this was subtraction, if this was negative, then this would be subtraction. Okay, so this sign determines the sign inside. And there we have it, factoring perfect square trinomials part 2. Hopefully you found this video helpful, and good luck.